Hello everyone, welcome back to P.Tech.chemistry channel. My name is Dr. Ont. In this tutorial video, we'll go through this 1 hour 15 minutes. This is paper 4. It's an extended theory paper for a very recent session, October-November 2022. Cambridge International, IGCSE Chemistry Extended, paper 4, variant 1 for the 0620 chemistry. In this first question, so we have got these names of elements. These are period 2 chemistry. So these are second row of the periodic table. So starting from lithium all the way to neon, you can use these once, more than once, or not at all. Identify the element which is a product of photosynthesis. Number 1, these are period 2 elements. We can see that they ask for elements which is a product of photosynthesis. So we do know that CO2 reacting with H2O in the presence of sunlight, and you also need the presence of chlorophyll in the green leaf in order to generate C6H12O6. So this is your glucose, your source of energy, your source of food. It's also going to release oxygen gas. Whatever equation we write at this level has to be balanced. 6 CO2 as there's 6 carbon, 12 hydrogen there, so there must be 6 water. And then you see the 6 oxygen get balanced by the 6 oxygen there. 6 times 2 is 12 oxygen. I need 6 oxygen molecule. Well, identify the element that has got to be oxygen there, as this is a compound and not an element. Part B has an oxide found in clean dry air. So clean dry air consists of around 78% nitrogen diatomic molecules, around 21% oxygen, and around 1% of other gases. So there is actually more than one answer. So there is nitrogen and there is also oxygen. So whichever one we write just one. So identify the element which has an oxide. Hang on. It cannot be nitrogen because this oxide is found in clean dry air. So in the 1% of other gases, we have CO2, we have some noble gases, but clean dry air does not have oxide of nitrogen. So this answer here must be oxygen and cannot be nitrogen because oxide of nitrogen is a pollutant there. Next one forms a basic oxide, that's number 1. So typically basic oxide refers to metal oxide. And then we look at this is formula of X2O. We know that oxide is O2 minus. In terms of lowest common multiple, the charges must cancel out. So we must have a plus 2, which is distributed over 2 of the X. So this must be X plus and X plus, such that 2 of them, and one of these, X2O, plus 1 is plus 2, added with minus 2 give you the overall compound charge of 0. So therefore, we're looking at group 1 metal ion. The only group 1 in the second row is lithium. So this has got to be lithium there, forming lithium oxide. Next one is the main component of fertilizers, used to improve crop growth, to enhance, to promote crop growth. So we talk about the NPK fertilizers. Phosphorus is in third period. So this is third period, third row of the periodic table. Potassium is in the fourth period. So the only second row element, second period element, there has to be nitrogen from the list there. Highest rate of diffusion, this is highest rate of diffusion, so this means this one has got to be the lowest AR. So in terms of the highest rate of diffusion, we're looking for the lightest. Of course, we don't think about lithium particle in that sense because this is a solid. I think this is a tricky question, isn't it? Highest rate of diffusion at room temperature. So think about gas. Think about the one with the lowest AR. So this is a solid. Carbon, diamond and graphite, those are solid. So really we're thinking about nitrogen, oxygen, fluorine, and neon only. So if we think about this is nitrogen versus oxygen versus fluorine versus neon. All of these gases are diatomic gases. We look at gases that can diffuse much more faster compared to solid. So that's why I'm not looking at solid. This is monoatomic or monatomic. So without even counting, you can tell that this one definitely has a lower mass compared to the rest, as these are all diatomic. So that one has got to be just neon there. Produces a red flame in a flame test. This is second period elements. So red flame, red orange belongs to calcium 2 plus ions. So Li plus there burns with a red flame. That is your test for cations. This is of the cations there. 5 electrons in each of its atom. Be careful. each of its atom, not outer shell. This is not outer shell, so therefore we are not looking at group 5. We are looking at 2, 3. We are looking at group 3 element, which in the second period that has got to be group 1, group 2, group 3. We are looking at boron instead. That is element number 5. So number of electrons equal to number of protons. This is in the element, that's in the atom essentially. Last but not least, oxide responsible for acid rain. So we know that oxide of nitrogen consists of N2O, NO2, etc., etc. So these are oxides of nitrogen. They are classed as a family of oxide of nitrogen, and therefore nitrogen there is the element that gives you the oxide of nitrogen that can form acid rain there. And that's it for the 8 marks first question. In the second question, so potassium is a group 1 element. Name and describe. So the name of the bonding is called metallic bonding. Within the syllabus, you're expected to be able to define or to describe how it is. So I think it's best if I actually draw a diagram showing the layers of cations. So what you have is layers of cations. The cations are kind of tightly packed because these are solid particles, but it does have delocalized electrons throughout the structure. So these are what you call delocalized electrons, and we have to label. When we draw a diagram, we have to think about labeling. These are your delocalized outer shell electrons because they have been lost from the outer shell. Whereas these positively charged things, these are cations. We do not have anions in metals because these are elements, metallic elements. So only one type of atoms, no anion. There is no anion because it's not an ionic compound. So our attraction is between the positive charged cations and the sea of delocalized valence electrons there. So what can we say? Maybe if I just move these up a little bit so I can have a bit more space. So what is metallic bonding? Metallic bonding is the electrostatic force of attraction. It's the strong electrostatic force of attraction. So electrostatic because positively charged cations are attracted to the negatively charged electrons, but these are not electrons in your shells. These are between the cations and also the sea of delocalized valence electrons. The valence there refer to the outer shell, so you can use either words interchangeably. And these are electrostatic. So these are strong attractions. So describe the bonding. Well, that's it really. I cannot say anything more than that. And you have these delocalized valence electrons. They are free to move. They allow you to conduct electricity. This strong attraction between them give you your high melting point in most metals, except for group 1 metals, which has a very unique characteristic of low melting point there. So potassium combines with sulfur to form an ionic compound. So this is K plus from a group 1 metal. And then you have a group 6 nonmetal, S2 minus. When we look at valency is what you call the combining power. So the combining power of these group 1 and group 6 nonmetals. This is going to be 1 and 2. Following the charges of the ions, take the value, and then you crisscross as you do lowest common multiple, primary school mathematics. How many means how many of these things on the left. So you got 2K plus and you have 1 of the S2 minus. The chemical formulation is 2 of the K and 1 of the S there. This is looking for physical properties of ionic compounds. So very straightforward there from the syllabus, high melting and also boiling points, as you have very strong ionic bonds between these oppositely charged ions in the giant ionic lattice structure. So structure and bonding, you gotta be able to state the structure first, and then you need very high amount of energy to break the strong ionic bond between the oppositely charged ions. Another physical property would be cannot conduct as a solid, but then it can conduct when molten, cannot conduct electricity when solid. So this is about conduction of electricity when solid because the ions are in fixed position, but can conduct when molten. That means when you become liquid, or if you can dissolve in water, that is called aqueous, and that is actually part of the electrolysis topic there. Now complete the dot and cross. Complete the dot and cross. The potassium form the K plus. The potassium has these dots. You originally have potassium 2881, and this thing has been lost. And where does this dot goes to? It goes to the sulfur. Sulfur started with 26, and then sulfur started with 286. Be careful. And then now you have S2 minus. This becomes 288. You have gained 2 electrons. This is from the potassium, having lost the dot. So I'm going to draw the outer shell. And when I draw the outer shell, originally I have 6 crosses because I started in group 6. I have 6 crosses, and now I have 2 dots because the first dot comes from one potassium and the second dot comes from another of the potassium atom, having lost electrons, having gained 2 extra electrons, and now have a 2 minus charge there for that 3 marks overall. Part C, this is about potassium chemistry. So metal plus water will give you your metal hydroxide. This is according to reactive metal chemistry of these group 1 alkali metals. And you also get this hydrogen gas. So apart from bubbles and vigorous reactions and the potassium floating on water as it gets smaller in size because it reacts, we also get a colored flame because this thing reacts vigorously and catches fire, and we have K plus. So this colored flame is of the cations. This is of the K plus cations, and this is going to be a lilac flame color, part of the flame test syllabus. Now this is a strong alkali. They want the formula of the ion, not the compound, the ion, responsible for alkalinity or very strong basicity. OH minus is the formula. The name is called hydroxide, but they want the formula, not the name there. What's the color of litmus? So this is just normal litmus. It's not universal indicator. It's a litmus. It's going to be blue in color. Now calculate the volume, and you want it in cm cube. Use the following steps. So the question tries to guide you step by step. So first of all, this is potassium. These are what you call mass. So this is using the idea of reacting mass. There are 3 formulas for mole. Mole equal to mass over mR. Mole equal to concentration times volume, where there is mole per dm cube. And then there is volume of solution in dm cube. Bear in mind that is to do with solution, and then we also have mole equal to volume of gas divided by 24. This is in dm cube per mole, and therefore the volume of gas must be in dm cube. That is for gas there. Whereas for the mass over mR, that mass is in gram, and mR is in gram per mole there. So we have 3 different formulas. We need to be careful about which one we use. So the potassium is given as mass. So the mole of the potassium, we label our work, we label our working so that we can be clear of what exactly we want to portray to the examiner who is marking our work. So 2.34 divided by 39, I get 0.06 mole. So next one, the mole of hydrogen gas form. Looking at the balance equation, we have 1 mole of hydrogen gas coming from 2 mole of potassium metal. 2 mole of potassium is to 1 mole of hydrogen gas. So 2 mole of potassium is to 1 mole of hydrogen gas. This is from the balance equation. And now I have 0.06 mole of that, and I get X. So you can do cross multiply. So 2 times X equal to, and the other directions, so 1 times 0.06, then X equal to 0.06 divided by 2, X equal to 0.03 mole of the hydrogen gas there. Now you have seen my other tutorials where I did this all in one go. So the mole of hydrogen is to the mole of potassium is 1:2, and then this is why I want to find the actual mole of the hydrogen. And then I have 0.06 at the bottom. It's the same strategy, it's the same mathematics. When I move the 0.06 to the other side, this becomes 1 times 0.06 divided by 2, which gives me 0.03 as well. So both method actually works the same way. It's just showing the ratio like this. This using fraction to show the ratio. Both method require labeling so that you don't lose track of what it's trying to do. So we got the mole of hydrogen gas. We want the volume in cm cubed. So this is going to be the volume of H2. If I use cm cubed, then I have to divide this by 1000, which will eventually give me division of the volume in cm cubed. And that whole thing is divided by 24,000 because it was 24 dn cubed per mole given at the bottom of periodic table. And this is equal to 0.03 mole. So the volume of H2 is going to be 0.03 multiplied by 24,000. As I move up the division by 24,000 to the other side, so 0.03 times 24,000, this gives me 720. Do not forget unit, this is in cm cubed there. And that's it for the 3 marks question. Part D, so this is a reaction with dilute acid with this base or with this soluble base called an alkali. Name the acid used. So you produce potassium chloride, so the acid you use will be hydrochloric acid. So not the formula. If you give HCl aqueous, that is wrong because they want the name of the acid. State the type of reaction. This is between an acid and a base. This is what you call neutralization reaction. What is the experimental technique that you use when salts are made? By reacting this is using a titration method because we are talking about aqueous there and we are talking about aqueous of the acid. So solution is solution, acid-base titration there. Part E, when we have silver nitrate there, all nitrates are soluble in water. So when we added it with aqueous potassium chloride, we do get a precipitate. So unlike the previous titration, this is what you call the precipitation reaction. You produce something insoluble. So aqueous and aqueous producing something insoluble there. So state the color. This is going to be AgCl solid precipitate and this is going to be white color. This is part of your practical chemistry or your alternative to practical chemistry where you need to know the test of chloride, bromide, and iodide. Name the precipitate, name it. So by right it should be silver 1 chloride, but usually silver only form silver plus 1, so we just call it silver chloride. Last but not least, write ionic equation. Number 1, include stat symbols. Number 2, this is a precipitation reaction. So there is the Ag plus aqueous from the silver nitrate, and then the Cl minus from the potassium chloride, and then this will give you AgCl solid. You will see that usually when you write this, you write the insoluble precipitate first, then one of the Ag plus, one of the Cl minus. It did not come from Ag and Cl or Cl2 because it's ionic equation. It came from the ions that was already present in this ionic compound dissolved in water. This ionic compound dissolved in water, but the NO3 minus and the K plus are spectator ion. Since all nitrates are soluble, all potassium salts are soluble as well. So all potassium salt, all nitrate salts are soluble in water. That's it really for this overall 23 marks second question. In this third question, ammonia is made in this process. This is basically called the Haber or the Haber process, whatever you want to call it. Well, that's actually the first question given in the question here. So state the raw material from which nitrogen is obtained. This is from the air because we got 78% nitrogen in clean dry air. So how are we going to get it from the air? We get it from fractional distillation of liquid air because they have different boiling points. So the different boiling points of the components in air, such as your oxygen versus your nitrogen, allows you to separate them based on their different boiling point there. State what is meant by this arrow here. This means reversible. So going from left to right is your forward, right to left, product to reactant is your backward reaction. just stating the temperature as well as the pressure. This is around 450 degrees Celsius. I believe in the syllabus they mentioned around 400 to 500 degrees Celsius is a compromised temperature. Your pressure needs to be quite high, around 200 atm. You do use a catalyst. This is to speed up the reaction, to make the reaction faster. In this Haber process, they want the name, they don't want the formula. This is just iron as an element. Iron as an element, not as a compound. Finely divided iron catalyst there. In part F, this is about reversible changes. So if the forward reaction is exothermic, it means that it releases heat to the surrounding. Releasing heat to the surrounding means the surrounding will get hotter, the temperature of surroundings will increase. What happened to the position of equilibrium when I decrease temperature? This is to do with the forward reaction is exothermic. So as temperature decreases, think about what happened. The equilibrium, which is the system which is the equilibrium, will try to oppose the change. It will try to resist the change. It will try to go opposite the change. It will try to increase temperature. But looking at your forward reaction is exothermic, you only know how to release heat. You want to make the outside hotter. You want to increase temperature of the surroundings. So what do? We say we can release, but are we going to release more heat or less heat? I want to make the surrounding hotter. I want to increase the temperature of the surrounding. So by releasing more heat to surrounding. Looking at the forward reaction releases heat. If I release more heat, therefore I will favor forward reaction. If I favor forward reaction, so that means my equilibrium will shift to the right hand side. So position there, equilibrium will shift to the right hand side. Now they just ask for stating the effect. So in fact, you only get the marks. You only get the marks for shifting to the right hand side. That's it. You don't get the mark for explanations. In certain type of questions where they say, oh, actually, I was wrong. Explain your answers. So there is a mark for explaining and also stating as well. So there is the first one, there's the second one. So I think I probably started off explaining and then I stated the shift in the position there. Hopefully that makes sense there. How about pressure? Pressure affects gases. So this is to do with counting the moles of gases on the left and on the right. So here you have 1 mole of nitrogen gas. Here you have 3 moles of hydrogen gas. And then you produce 2 moles of ammonia gas. So altogether, you got 1 plus 3, you got 4 moles of gases on the left versus 2 moles of gases on the right. So we have 4 moles of gases. A lot of students, they forget to, state that these are gases. There are 4 moles of gas on the left, 2 moles of gases on the right. So what happened there is, when pressure increases, probably not yet stating the changes. When pressure decreases, because they talk about reducing the pressure. So what would the equilibrium try to do? The system of the equilibrium will try to increase pressure. How do you increase pressure? You will want to shift to the side with the more gaseous molecule. So by shifting to the side with more gaseous molecule, and based on our first statement, there will be shifting to the right hand side. Is it? No, yeah, they'll be shifting to the left hand side because you want to shift to the side with more gaseous molecules. So I will shift to the left hand side, favoring for backward reaction. That's it for that 4 marks reversible changes question. In part G, explain in terms of particles. So we must talk about the particles, collision theory, because this is about rate of reaction. So we're talking about collision theory, but not just collision theory on its own for rate. This is also to do with kinetic particle theory, which is to do with temperature as well as what happened to the particle there. Kinetic particle theory. When the temperature is decreased, reduce means decrease. So when temperature decreases, the first thing we notice in terms of kinetic particle theory is that your particles will have lesser kinetic energy, because kinetic energy is related to temperature. Temperature is a measure of your average kinetic energy of particles. When particles have lesser kinetic energy, therefore, they move slower, and also they will collide less frequently. This is about the collision theory. So when they collide less frequently, this results in less successful collision or less effective collision. Less effective, or you can say less successful collision. So therefore, overall rate of reaction would decrease. So overall rate of reaction decreases, the reaction slows down. So they wanted you to state what happened to the rate. There's your third explanation. That's the third point. The first point is about lesser kinetic energy. Second point is about less frequent collisions and less successful collisions. Overall rate of reaction decreases. They give you your 3 overall points there. Part H, last bit of this question. When ammonia acts as a base, this is a very special type of neutralization. Not really special in any sense, it's just that usually neutralization will produce salt and water. But when ammonia acts as a base, there is no water. You will just get the salt simply because to balance the equation. You're going to get ammonium sulfate. This is NH4 plus. SO4 2 minus come from the sulfuric acid. 1 and 2, these are based on the valency, based on the charges of the ion. We just bring down the value. We crisscross because that is what you call lowest common multiple. Your objective is to cancel out the charges. So how many of these ions do you need? 2 goes to the left, 1 goes to the right. So how many of these things on the left? You need 2 of them. So I'm just going to write down 2 of them so that I can see it very clearly that the +1 and +1 cancel out -2 charge such that I will get NH4 in a bracket because to represent 2 of these, and then SO4. Ammonium sulfate there. So NH4 twice SO4. Having said that, I need to balance my questions. I have 2 of that NH4 coming from 2 of the NH3 and 1 of the sulfate coming from 1 sulfuric acid. 4 times 2, there is 8 hydrogen. As you could see there, 4 plus 4 is 8 hydrogen. And you have 6 hydrogen there because of 2 ammonia, plus another 2 hydrogen that give you 8 hydrogen there. They want the formula. The name is ammonium sulfate. We would use bracket NH4 twice SO4. This is called ammonium. It's no longer ammonia. Ammonium sulfate. You produce a salt when the H plus of acid get replaced by different cations. Usually it will be metal ion, but here this is non-metal kind of cation. So this is your ammonium ions stated in the syllabus. Practical paper, alternative to practical paper, vocabulary, 14 marks, overall question there. Question number 4, so we have preparation of calcium nitrate. So we know that all nitrates are soluble in water, and this is important in your salt preparation. We have this calcium carbonate with dilute nitric acid. Write a chemical equation. Make sure that when you write chemical equation, it's always balanced. So this is between a calcium carbonate, Ca2 plus, CO3 2 minus. Lowest common multiple says that, +2 cancel out -2, so you just need 1 of each. Calcium carbonate there. Nitric acid, HNO3. And then you need get calcium nitrate, Ca2 plus, NO3 minus. Now the charges don't cancel each other out anymore. 2 and 1 there. So when we exchange the valency, we have 1 calcium 2 plus, we have 2 NO3 minus. You can see the formulation as given in the question originally is 1 calcium and 2 of the nitrate there. You also get carbon dioxide as the test for carbonate reacting with acid to give you effervescence, which turn lime water milky there. And you also produce water. So we have 2 of the nitrate. So I'm just going to put 2 HNO3 there. 2 hydrogen combined with 1 oxygen there, giving you water. This one losing the oxygen to the 2 hydrogen to form water is left with CO2 there. Describe 2 observations. Describe. So we get rapid bubbling. Rapid bubbling is also known as effervescence, or you can say very rapid bubbling was observed. What else do we see? We will see the calcium carbonate dissolve into the solution as calcium nitrate is soluble there. So the calcium carbonate solid reacts, and as it reacts, it will get smaller in size. It dissolves into the solution because the product is soluble. So this is about the soluble product. This has got nothing to do with the solubility of carbonate, because group 2 carbonates, like a lot of carbonates, are actually insoluble in water there. Part C, the student continued to add calcium carbonate until it is in excess. So calcium carbonate, as I mentioned, is insoluble. We all know that it's only ammonium carbonate, potassium carbonate, sodium carbonate that are soluble. So all the rest of the carbonate are insoluble, which means that we will see the solid remaining at the end. Then the student removed the insoluble excess calcium carbonate by filtration. So what is this general term? To the solution collected. The solution is the soluble stuff that passed through the filter paper. So this is actually what you call the filtrate, because the solid that is left behind, which is insoluble, that is what you call the residue. So residue is what you got left behind the filter paper. Filtrates the solution that passed through that. Part D, so this is about the process of crystallization. In the essay leading up to the process of crystallization, we talk about heat the solution until saturated. So this is a solution with the maximum amount of solute. So you have the most amount of solute, maximum amount of solute. This one is dissolved in a given volume of solvent. And what is very important is solubility changes with temperature. So this one is at a particular temperature or at a fixed temperature, because when I increase the temperature, I can change the solubility, therefore I can change your level of saturation. Now you have a hot saturated solution. How crystals are produced, this is the next step in the crystallization assay. So you know that you have a solution, you don't see solid inside, so you just allow the saturated solution, which is hot, to cool down, and crystals will form slowly when it cools down. So this is because at room temperature, the solubility is not as high anymore. Therefore, as it comes out and cools down, the crystal will start to come out as it cools down back to room temperature there. Part E, so the term used to describe calcium nitrate after you remove the water of crystallization. So this was the water of crystallization removed. So, well, actually water crystallization is not in the H2O removed. Water crystallization is the .xH2O inside the original hydrated compound there. So this is now without the water crystallization. So this term is what you call anhydrous. This is hydrated, this is anhydrous. You have removed the water crystallization there. So first part here, we got to determine the value of X, use the following steps. So the MR of that calcium nitrate, when we think about it, we have one of the calcium, which is MR of 40. We have two multiples of nitrate. So I'm going to put a 2 outside and then a big bracket for the thing that's inside. There is one nitrogen, so 14 times 1 plus 16 times 3. So the whole thing is just going to be, if I do the bracket first, 1 nitrogen, 14 times 1 plus 16 times 3, multiplied by 2, and then added that with 40, and I get 164 there. How about determining the number of moles? So here we have the MR, and we were told that there is 2.46 grams. So this is what they call reacting mass. So if you have reacting mass, you think about mole. So the mole is just going to be your mass of MR. So there's 2.46 divided by 164. And I get 0.015 mole there. So what happened with the value of X there? So we think about what has happened. We have removed 0.0600 mole of H2O. We look at the balance equation. This is the mole of H2O given out. This is 1 mole. So we can say that the mole of water is to the mole of the calcium nitrate. I'm just using ratio, to be honest. This small n represents mole there. So what happened there is there's X mole of H2O, and there is also X mole of, there's also 1 mole of the calcium nitrate. So that's from the balance equation. That's from the balance equation. And now if I put this all in, I will put in the actual data now. So the mole of calcium nitrate form is 0.015 mole from the actual experiment. Together with it, you also kick out 0.0600 mole. That's 0.0600 mole. So x divided by 1 is just x. Then 0.06 divided by 0.015, I get 4 exactly. This is a whole number. So there's 4 molecules of water in the water crystallization there. Nitrates decompose on heating. This is part of the IGCSE syllabus. So sodium nitrate, when they decompose, there is your Na plus NO3 minus. You're supposed to get the oxide. So Na plus O2 minus. So you can see 1 and 2 based on the charges of the ions. Plus 1 give you 1, minus 2 give you 2. We are just exchanging the valency to get how many of these ions we need. We need 2 of the Na plus in order to cancel out the charge of the O2 minus, such that the formulation is 2 of the Na and 1 of the oxygen. And we also get NO2 gas. And let's see if we can balance the equation. So 1 of that, 1 of that. And I think that you do get oxygen as well. I haven't done this for some time, but let me see if I can balance the equation without oxygen. So if I have 2 NO2, 2 Na there, because I would have 2 Na, I put 2 there. So 2 of the NO3 give me 2 of the NO2. And yeah, I do need the oxygen in order to balance the equation there. So it does behave like group 2 nitrate, where it gives you the metal oxide, the nitrogen dioxide, as well as the oxygen gas. This is a brown colored gas, and I haven't balanced my equation yet. That's why it's 2 marks, yeah? 2 Na, 2 Na. 2 of that NO3 give me 2 of the NO2. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6. You only have 5 so far, 4 plus 1. So what I can do is I can put a half in front, because a half multiplied by 2 atoms in one molecule equal to 1. So this gives me 1 oxygen atom, plus 4 oxygen atom, plus 1. This gives me 6 oxygen atom. Some teachers and some students really don't like, fractions, although it's entirely correct. So I can just multiply the whole thing by 2. Overall, this is a mathematics kind of ratio. So you just get 1, 4, 2, and 4. I would say both of them are actually correct. Both of them will be accepted by any competent and qualified chemistry teachers and chemists. Okay, that's it really for this 14 marks overall question. Question number 5, we have organic chemistry finally. This is ethene, it's part of the alkene family. This is what we call these unsaturated hydrocarbons, because you have carbon-carbon double bond. What's the general formula? Very straightforward, CnH2n there. You can see that 2 times 2 is 4, CnH2n. The test for alkene, you bubble the alkene, the gaseous alkene, because this is a gas at room temperature and pressure, into aqueous bromine. Aqueous bromine, as stated in the syllabus, is orange or orange-yellow, whichever color you want, orange, orange-yellow, or yellow. And it will go colorless, because going from something with bromine to something that is without bromine, this is also known as a redox. It is redox because you go from bromine 0 to bromine minus 1 in your product. So having done that, you can see there is a change in your oxidation number. Oxidation number decreases there, so that is your reduction. So that means the other species must be the reducing agent, as it reduces the Br2 to become Br minus 1. Itself will have been oxidized. So there you go, you got your redox reaction there. But of course, this is in organic chemistry, we call this an addition type of reaction here. So only one product is formed. That's why they tell you this information. I cannot put down redox because based on this information, there's nothing about it which is redox, this type of organic reaction. Okay, so when you form only one product in the reaction, this is what you call addition reaction. Part of the energy profile diagram is as shown. So this reaction is exothermic. So that means the delta H is lesser than 0. So that means the system releases heat to the surrounding. So energy profile diagram belongs to the system. So what I'm trying to say is, if this is the reactants going from left to right, going from starting reactant to the product, you are going to end up with lesser energy for the product. So the product was C2H4Br2. So it was C2H4Br2. So we can see that if this is your energy, this is going down as that is your delta H lesser than 0 there. And what do they want? Position of the product? Yes. Arrow to show activation energy. I haven't done that. Activation energy from the starting energy level of the reactant to the top of the peak. That is your EA. Oop, hang on. If you read the question, they want it labeled as A. So be very careful, read the question. Arrow to show energy change. This is your delta H, which I've labeled delta H is less than 0. Just like that, 3 marks in the overall question there. In this question, so we have been given a couple of these bond energies. So these are all covalent bonds that we started out by looking at the total energy required to break all the bonds in the reactants, and then we're gonna consider the energy release in making all the bonds in this product, and then we're gonna use the combination of these total energy absorbed for breaking bonds minus or subtracting then the total energy release when you make new bonds, and that's going to give us the enthalpy change for reacting 1 mole of these relative to 1 mole of that, giving us enthalpy change in kilojoule per mole. But let's just consider what we need to break. If we look at the structure on the left, we are breaking one of these carbon-carbon double bond. So it's all about bookkeeping really. 1, 2, 3, 4. So 4 of that CH covalent bond and 1 of these BR covalent bond. Looking at the table, there will be CC double bond. So 610 multiplied by 1. 4 times CH, 410 multiplied by 4. Last but not least, 190 multiplied by 1. So I'm going to add these up together as these are the total energy absorbed for breaking bonds. What are we forming? We are forming 1 times CC single bonds, so that is 350 multiplied by 1 as we are forming 1 CC single bond. 1, 2, 3, 4. 4 times CH covalent bonds, so that is 410 multiplied by 4. We're also forming CBr and CBr, so those are the new additional bond that we formed following the addition of BR onto the double bond of the alkene. So that's 290 multiplied by 2. Again, we're going to do the same thing. We're going to add up the total energy that are being released when you form new bonds. So the first bit there, energy needed to break the bond. If I move this up a little bit, and we're just going to sum this up. 610 times 1 plus 410 times 4 plus 190 times 1. I get 2440 kilojoule there. In terms of the energy release when we form new bonds, based on what we have just analyzed earlier, we can see that we're just going to do the sum again. There will be 350 multiplied by 1 plus 410 times 4 plus 290 times 2. So we're going to release this much energy when we form all the bonds in the product. So determine the enthalpy change, the energy change is going to be the total energy for breaking bond. So that's the energy for bond breaking minus the total energy release when you form new bond. So when you make new bonds, you're going to release energy. So energy for breaking bond, 2440. So that will be 2440. Take away 2570. What I'm going to get overall is negative 130 stated in on the periodic table. Sorry, not periodic table. What am I talking about? On my calculator. So that is basically your sign, your value, and your unit, and this is essential for enthalpy change. And you see that I'm back to kilojoule per mole. By right, these are kilojoule and kilojoule. The kilojoule per mole means per mole of what is reacting. So we're looking at 1 mole of this reacting with 1 mole of that. So this is stoichiometric quantity, how much energy for 1 mole of the reactant that. So minus 130. Sign, value, and unit for this overall 3 marks calculations. Here they ask you to break it down into step by step, but if they didn't give you the steps, you should be able to do the calculation as well based on total energy for bond breaking minus the total energy for bond forming there. That's it for these 3 marks. That's it for this overall 9 marks question there. Number 6, this is about ester. So we have the C double bond O. There's our ester linkage. So in this ester, this is where we actually form the new ester bond. On the left hand side, these are from the carboxylic acid. How do I know it's from the carboxylic acid? Here's got the C double bond O. The carboxylic acid will have lost the OH when you form ester, and on the left hand side there is no C double bond O, so therefore it's from the alcohol, and the alcohol will have lost the H there. So name the ester. So your alcohol there is from methanol because it's one carbon. So this is one carbon alcohol. You will name the alcohol first. So this gives you the methyl. And then the carboxylic acid is one carbon carboxylic acid. So that is what you call methanoic acid. And kind of like forming salt, the ester of methanoic acid is what you call methanoate. Now, did you use the empirical formula? So this is the simplest whole number ratio of atoms as stated in year 9 syllabus. This is of the atoms or the ions, but here this is of the atoms. Must be in the simplest whole number ratio. Whole number ratio, there should be number there. So if we total up the actual number of atoms, there will be C2 because there is 2 carbons, 1, 2, 3, 4 because there is 4 hydrogen and 2 oxygen. This is what you call the molecular formula. But you could see that we could divide 2:4:2. Divided by 2 throughout, I'm going to get 1:2:1. If I divide that by 2, let me just make that clear. Divide by 2, and that means I'm going to have 1 carbon, 2 hydrogen, and 1 oxygen as the empirical formula there. Now, in terms of the ester, we got to complete the dot and cross diagram. So I think they've shown the inner shell of oxygen and the carbon as well, which make it a bit tricky there. Anyway, so this is a single bond between carbon and hydrogen. This is a single bond between carbon and hydrogen. Carbon is already dot there. So I'm going to say dot, and then I'll just use cross for hydrogen as well. Probably not. I don't think that's probably a good idea. Let me just use triangle. Triangle for hydrogen, cross for oxygen, dot for carbon. So what do I have there? I have a double bond between carbon and oxygen. Double bond means carbon share 2 electrons, oxygen share 2 electrons. So what can I say? Oxygen share 2 electrons, and then the carbon share 2 electrons like that. And what else? I have a single bond between the carbon and oxygen. So carbon share 1, oxygen share 1 there. This is the CO single bond. So oxygen give me 1 cross, carbon giving me 1 dot. And this oxygen started with 2 6 electronic configuration. We talk about in the outer shell there's 6. You already share 2, therefore you're left with 4 more crosses. So 1, 2, 3, 4. You can see that 2, 4, and 6 in the outer shell, and 2 in the inner shell. Share 2 more from the carbon, double covalent bond. This carbon, 1, 2, 3, 4 dot in the outer shell. This oxygen, I think single bond to the carbon, so should be able to work this a bit faster now. Single bond to the carbon there, so single bond there, and then CH is all single bond. Oops, I mean like this, and then this. Don't forget your triangle for the hydrogen. So triangle for the hydrogen, and this is single. Oxygen, 6 electrons in the outer shells. You already use 1 and 2. You're left with 4 more, and should be able to check that this oxygen has 1, 2, 3, 4, 5, 6 electrons in the outer shell originally. It's just about translating the display formula based on the single and double bond correctly into counting electrons, including the outer shell electrons, for these 3 marks dot and cross exercise there. Part C, ester Y can be made by reacting 2 organic compounds together. Name the compounds and draw their structures. I think I did name the compound earlier. It was methanoic acid as well as methanol. So whichever one you draw first doesn't matter, but they want you to draw display formula, show all the atoms and all of the bonds, especially O and H like that. So CH3, and then OH, there's methanol, And then if I draw out the methanoic acid, the one carbon carboxylic acid, I'm going to get CH3. Oops, hang on. No, I do not get that. Carboxylic acid has CO or H, but you only have one carbon. So that means the only remaining atom there must be just hydrogen. This is methanoic acid there. D part 1, what is meant by structural isomers? So we know that isomers in IGCSE level, they are all structural isomers. They have the same molecular formula, but different structural formula. So same molecular formula, but what is different? Different structural formula. So in terms of the actual number of atoms in the whole molecule, they will be the same. But in terms of their functional groups or positions or straight chain versus branch chains, they will have different structural formula. Next up, name a carboxylic acid, which is a structural isomer of ester Y. If we look at ester Y, the molecular formula was C2H4O2. That was what I have calculated earlier based on counting the actual number of atoms. Now, they want an acid, so look for 2-carbon carboxylic acid, and that will be your ethanoic acid. So ethanoic stands for 2-carbon, is a carboxylic acid. I draw COOH first, but then 2-carbon, so I add another carbon, but there is no more carboxylic acid, so it's just C2H4O2, and you could see same molecular formula. Previously, this was the ester, this is now the carboxylic acid, different structural formula for the carboxylic acid. Ethanoic acid is a structural isomer of the original ester earlier. That's it really for this 12 marks question. And I think that's it really overall for this paper 4 variant 1 for this October-November 2022 0620 IGCSE chemistry for this Cambridge International. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. And do let friends know about the channel so that they can benefit more from what I have to offer on the channel. Thank you for watching again. See you in the next tutorial video.